All right, this is section 9.5, periodic trends in electronegativity. So we've been doing a lot of trends, this time electronegativity. All right, so be able to define it, be able to describe the trends, and be able to use those to predict the relative electronegativities of those atoms. All right, so what is it? Well, first of all, electronegativity is the ability of an atom to attract. It's how attracted it is to other electrons out there, how much it wants to take an electron from another atom. The higher the electronegativity, the greater its ability to attract electrons. And when they say shared electrons, they mean like when you're forming an compound, it's how much more likely it's going to be to take that electron from the other atom. And if, in the last section we were talking about ionization energy, if we think of ionization energy as like security, like in a bank, it's how well you guard your money, or how well do you guard your electrons. That's ionization energy. The higher the ionization energy, the harder it is for somebody to steal your electrons. Electronegativity would be how good you are at stealing something. So how good a thief you are, how well you can get an electron from somebody else. And it's interesting that if you are really good at guarding your money, you are also a good, or guarding your electron, you're also a good electron thief. Those two go together in the terms of the atoms. Now, the scale that we will use, and there's different ways to do it, but probably the most common one is known as the Pauling scale, named after an American chemist, Linus Pauling. Probably considered probably one of the leading chemists in the last 100 years. And he came up with kind of a scale for electronegativity. And the scale ranges from 0 to 4, or really I think the lowest one on the chart is like, well, I guess actually the noble gases would be at 0. But of the atoms that actually react, 0.7, I think it's the smallest. Fluorine is our most electronegative element. Okay, so it's really close to 4, I think like 3.98 or something like that. So the most electronegative, that's the one that's really good at taking electrons from somebody else. Cesium, francium, those are the bad ones. They are the worst at hanging on to their electrons, and that's because those are the really big atoms, and the bigger you are, the harder it is to keep those electrons. And you're also not trying to get more, Now, the noble gases, when we look at the noble gases, they don't have any electronegativity. So technically, I guess they would be the zeros, because they have no desire to get an electron. In order, think about a noble gas. Let's say we're talking about neon. It's got 8 in that outer level. If it took another electron, not only would it have to try to figure, take energy to get that electron, but it'd have to put it in a whole nother level and would make that atom very unstable. So it has no desire whatsoever. In fact, that's why for a long time they never could find noble gases, because they don't react with other elements and form compounds. They're happy like they are. They don't want to make a compound with anything else. So in terms of trends, as you go from left to right, you're getting bigger. This is just like ionization energy, and just the opposite of the size ones. And really, it makes sense. It is, the smaller the atom, the easier the harder it is for ionization. The smaller the atom, the easier it was for it to hang on to it. And, the smaller atoms are also ones that are going to have more charge to pull in another one. Decreases as you move from top to bottom. So in general, increases as you go up and to the right. Atoms with low ionization energy also have low electronegativities because they don't have a strong attraction for electrons. They don't want them. In fact, the ones with, like in the group 1A elements, they'd like to get rid of that electron. Then they can drop down and lose a level and have a full 8 in their outer level after that. So that's what they like to do. So once again, on your chart, this is what I want to see you do. Write down your arrows, and always do it so that it points to the biggest one. So going up, going to the right, but I want you to put an X over the noble gases, because we don't, or even maybe X them all out if you want to on this chart, probably not on your big blue one, but on each of these, label it so that you know what each of these things are on your own chart, because it's good for you to kind of have that. Now, obviously, on the test, you need to know them. You need to be aware of them. But really, there's only two major trends. It's either getting bigger as you go up and to the right or down and to the left. And you just need to remember which one's which. And if you just remember that the big one is francium, then you always know the size ones go that way and the other ones go up and to the right. And there you have it.